Welcome to the Data Sufficiency course from Chiron GMAT. There will be 4 videos on this topic. This first one explains the data sufficiency question format and introduces an essential tool called the DABC grid. Let's get started. A data sufficiency problem consists of 1 question, 2 statements, and 5 answer choices. To see how this works, let's look at a simple example. The question is, how many marbles does Anne have? And the statements are 1. Anne has 3 more marbles than Bruce. 2. Bruce has 47 marbles. Your job is to figure out whether the statements provide enough information to answer the question. This goal is reflected in the answer choices, which are the same for every data sufficiency problem. To give yourself time to choose the right answer, please pause the video now. If you picked C, you're right. Neither statement alone is sufficient, but both statements together are sufficient. Here's why. To determine how many marbles Anne has, it's not enough to know that she has 3 more than Bruce. And it's not enough to know that Bruce has 47 marbles. But if we combine these 2 pieces of information, we can see that Anne has 47 plus 3 equals 50 marbles. And that is sufficient to answer the question. Let's talk more about the answer choices. Because these same answers appear on every single data sufficiency problem, it pays to know them inside out. To help you with this, I'm about to show you an easy way to understand and remember them. Here we have a generic data sufficiency problem with a question and 2 statements. It's helpful to write down the letters for the answer choices in the following pattern: D, A, B, C, E. What you are looking at is the DABC grid, invented right here at Chiron GMAT. This grid lays out the logical structure of the answer choices. Let's consider each answer separately, beginning with D. D says, each statement alone is sufficient. In other words, statement 1 all by itself is sufficient to answer the question, and statement 2 by itself is also sufficient. As you probably guessed, the little s's here are short for sufficient. Let's turn to an example where D is the answer. The question is, what is the value of x? Statement 1 tells us that x equals 5 minus 1. This implies that x equals 4, so statement 1 is sufficient. Statement 2 tells us that x equals 2 squared. This also implies that x equals 4, so statement 2 is also sufficient. Because each statement is sufficient, the answer is D. To help us remember the meaning of D, we can use a heroic analogy. Here we have Hercules single-handedly defeating a lion. Let's say that this ability to triumph alone is the defining characteristic of a hero. In other words, a hero needs no help. Then each of our 2 statements is a hero, because each is sufficient by itself. Thus, D is the scenario of double heroes. All right, let's move on to answer choice A, which tells us that statement 1 alone is sufficient, but statement 2 alone is not sufficient. We can represent this by giving statement 1 an S for sufficient and giving statement 2 an I for insufficient. Here's an example. The question asks, is integer n even? An integer, by the way, is a whole number, like 2 or 3, but not like 2.5. Statement 1 informs us that n is a multiple of 4. This means that n is a number such as 4, 8, 12, 16, etc. All multiples of 4 are even, so statement 1 implies that n must be even. Thus, statement 1 is sufficient to answer the question. Statement 2 tells us that n is a multiple of 3. This means that n is a number such as 3, 6, 9, or 12. Some of these, such as 6 and 12, are even, but others, such as 3 and 9, are odd. Therefore, statement 2 fails to tell us whether n is even. It's saying, maybe yes, maybe no. This indecisiveness means that statement 2 is insufficient. Putting this in terms of our heroic analogy, A is the answer when statement 1 is the lone hero. All right, let's move on to answer choice B. B is like a mirror image of A. It says, statement 2 alone is sufficient, but statement 1 alone is not sufficient. This time when we label our statements, statement 2 gets the S for sufficient, and statement 1 gets the I for insufficient. To get an example where B is correct, let's modify the example we just used for A. We'll keep the same question, but we'll move the old statement 1 into position 2, and move the old statement 2 into position 1. In this new configuration, statement 1 is insufficient, and statement 2 is sufficient. So the answer is B. In terms of our analogy, B is correct when statement 2 is the lone hero. Now that we're done with B, let's look at answer choice C. This says, both statements together are sufficient, but neither statement alone is sufficient. Let's label our statements to show what this means. The part that says, neither statement alone is sufficient, means that we should put I for insufficient next to 1 and 2. For the part that says, both statements together are sufficient, let's make room for the combination of statements 1 and 2. We can call this combination the united statement, or U for short. Let's see an example where C is the answer. The question is, what is the value of y? Statement 1 tells us that x equals 5. This does not even mention y, so it must be insufficient. Statement 2 tells us that y equals 7x. You might think that this is sufficient, since we just saw that x equals 5. But it's too early for us to be combining the statements. Imagine a cloud settling over statement 1, so that we are forced to consider 2 strictly on its own merits. 2 simply tells us that y is 7 times an unknown quantity, so 2 is insufficient. Now that we have evaluated the statements separately, let's consider them together. To build the united statement U, we can start by copying the equation y equals 7x from statement 2. Since statement 1 tells us that x equals 5, we can replace the x in this equation with the number 5. The equation now tells us that y equals 35, so the united statement is sufficient. As a quick summary of C, we can say that here the statements are only sufficient together. Notice the contrast with the answer choices we looked at earlier. In D, A, and B, there was always at least one sufficient statement. We compared those sufficient statements to heroes on the grounds that a hero needs no help. To extend the analogy, we may say that here in C, the age of heroes has drawn to a close. There's no Hercules or Wonder Woman anymore. 1 and 2 are now just a couple of ordinary folk who must work together to get the job done. All right, now that we're finished with C, we're ready for the last answer choice, E. This one says that statements 1 and 2 together are not sufficient. The phrase statements 1 and 2 together refers to the combination of 1 and 2, which is the united statement U. Answer choice E is saying that U is insufficient. Now, if 1 and 2 are insufficient even together, then neither of them can be sufficient by itself. So we put an I next to 1 and 2. Let's turn to an example where E is the right answer. The question asks whether integer n is prime. In case you are a bit rusty on prime numbers, recall that most integers can be broken down into factors. For example, 210 is 21 times 10. Continuing this process, 21 is 3 times 7, and 10 is 2 times 5. But now we've reached the end of the line. 3 has no factors other than itself and 1. The same is true of 7 and 2 and 5. These red numbers are prime because they can't be broken down into smaller factors. So that's what prime numbers are. For this problem, it will be helpful to jot down the first few primes: 2, 3, 5, 7, 11, 13, etc. Now we're ready to tackle the statements. Statement 1 tells us that n is greater than 8. This means that n could be a prime number, for example, 11 or 13. But it also means that n might not be a prime number, for example, if n equals 9 or 10. Statement 1 fails to give a clear yes or no answer to whether n is prime, so statement 1 is insufficient. Statement 2 tells us that n is less than 12. This means n might be a prime number, such as 7, or a non-prime number, such as 6. So statement 2 is also insufficient. Now it's time to think about statements 1 and 2 together. Let's combine them to build the united statement U. From statement 1, we know that n is greater than 8, and from statement 2 we know that n is less than 12. Remember that the question describes n as an integer. The united statement is telling us that this integer is between 8 and 12. In other words, n equals 9, 10, or 11. If n is 11, it's prime, but if n is 9 or 10, it's not prime. So we still don't know whether the answer to our question is yes or no. Thus, our united statement is insufficient. To summarize what E means, let's contrast it with C. In C, the statements were insufficient individually, but sufficient together. C was a case of successful teamwork, saving the day in the absence of a hero. Well, no such luck in E. Even when they join forces, the two statements come up short. In other words, these guys are hopeless. And that's it. We've covered all the answer choices in the DABC grid. All that's left in this video is a quick review. Let's bring out the DABC grid one more time and breeze through the answer choices. D is the case where each of the two statements is sufficient. This is the scenario of double heroes. A is where 1 is sufficient but 2 is not. Here, 1 is the lone hero. B is the mirror image of A. Here, 2 is sufficient and 1 is not, which means 2 is the lone hero. Finally, C and E stand apart from the other answer choices. Here we have entered a zone without heroes. In other words, for C and E, statements 1 and 2 are insufficient. To distinguish between C and E, we need to consider the united statement, which is the combination of 1 and 2. C says that 1 and 2 are only sufficient together. That means the united statement is sufficient. In contrast, E says that the united statement is insufficient. So E is where the statements are hopeless. And that brings us to the end of this video. Thank you for watching, and I hope you'll join me for the next one. If you do, you'll learn a 4-stage method for solving any data sufficiency problem. The DABC grid will be essential. You'll use it to guide you through the process of eliminating wrong answer choices. For example, like this, or like this. Look for that and more in Part 2 of the Introduction to Data Sufficiency from Chiron GMAT.